Hello and welcome to another video. In this video we're going to be working on maximum distance in arrays. And in this one you're given m arrays where each array is sorted in increasing order, and you can pick two integers from two different arrays, each array picks one, and calculate the distance. The distance is just the difference, the absolute value of the difference. Return the maximum distance. So in this, the biggest you can pick is a 5 here and one of these two ones, and you get a 4. And then here you just have two arrays with two numbers, so you just pick these two because that's all you have, and you get 0. So first, when you read this, it sounds really simple. Like it's like, well, let me just get like the biggest number and the smallest number. But there are some tricks because like you need to make sure that the biggest and the smallest number aren't in the same array. And you can also recognize that if I have a bunch of arrays, I don't really care about anything in the middle. All I care about is the biggest and the smallest number. So all I care about is the last one and the first one. And then some combination of that is your answer. Like some last one, some first one with another array is your answer. You also can't compare every two arrays. You can't compare like this array to this array and then like this array to this array and this array to this array, because that would give you n squared. So that wouldn't work either. I think some people ask like, what algorithms do you get rid of? And like, how do you think of stuff? So like here, this is how many arrays you have. So you can't do like an m squared solution because that would be too big. So I was thinking of doing some other things, maybe like take the biggest and the smallest number in every array and put that into like a new array and then have them sorted, and then also write like what array they're in. And something like that probably does work, where you have your number sorted in like, you know, number and then the index of the array it's in. And then you just make sure you pick like the smallest number and the biggest number that are in different arrays. Something like that probably works. But there's something even easier. And so instead of comparing every two arrays, we can just go down the list and compare arrays, and then we can store the minimum and the maximum encountered so far. So we would say is like, okay, we'll compare these two, and we'll try like the biggest here with the smallest here, and then the smallest here with the biggest here, and then we're going to just store the biggest and the smallest encountered so far. So we'll store the 1 and the 5, and then we'll use those and compare to the next array and so on. So as you're adding more arrays into the arrays you compare, you're basically, as you encounter a new array, you're going to compare it to every single array before it, because we're going to be storing like if we have a bunch of arrays, right? Like if we have a bunch of arrays and we're on this one and we want to compare it to all the arrays before, well, all we need to know from the arrays before is just what's the smallest number in those arrays before and what's the biggest number in those arrays before. And so by just storing that and going down the list, we're able to actually compare everything, but in linear time. So let's kind of have like an example of that maybe. Yeah, but yeah, it's going to be pretty simple. So I guess maybe we can just have like a few of these. So let's say all our arrays are, I guess we can just say all our arrays are length 2 because, as we said before, we only care about the min and the max. So let's just say we have like 5 of these or something. So like I said, you can't brute force where like I compare here, I compare here, I compare here. I can't do that. But what you can do is, so let's say this is like a 1 and a 5, 2, 5, 1, 8, 10, 20, and like, I don't know, let's see how good this example becomes, but whatever. Okay, so essentially what we can do is, so ideally, if we can compare every array to every array before it, like if we can do that comparison in O of 1, then we're going to have a linear time solution, right? If we can compare every array to every array before it, so once we get to this array, we can compare to all of these, then we're going to do like all the comparisons that way. And so basically the idea is once we get to this array, if we know the max and the min from all of these, then we can do that, because we just need the max and the min from all these and this current array. So let's walk through how this will work. So first we'll just take the max and the min from the first array. So the min will be 1, the max will be 5. Then we go to the second array and we say, okay, and let's store a result variable. We'll make it 0 to start. So once we go to the second array, all we have to try is the max of the second array minus the min we have so far. So that's 4. And then the other way, the max that we have so far minus the min of this array. So we have 4 and we have 3, and the best is 4. And if you think about it, like no matter where your stuff is on a number line, that will always work. So just to give you some examples. Let's say the min and the max we've encountered so far is like 1 and 5, and our new array is both numbers above it. So the answer here is always, is it going to be the biggest number in this array minus the smallest number in this array? And we do that, right? We do the biggest number in this array minus the smallest number we've seen so far. And the other way would also work. So let's say the biggest and smallest encountered so far is 1020, and our new array is 15. In this case, the answer would be the biggest number we've seen so far minus the smallest number in this array, which we also do. So we can write that down. The two things we check for is biggest we've seen. Maybe you can move it actually. Biggest we've seen minus smallest from current, and the biggest from current minus the smallest we've seen. Okay. And yeah, so in this case, this would also work. So in this case, it would be the biggest we've seen minus the smallest from current would give you the best, which is this one. Now let's say they actually intersect in some way. So let's say this is 1020. Let's try like this current array is just in the middle. Maybe it's like 12, 18 or something. So the best thing here is going to be, I think, 20 minus 12. Yeah. Or it's going to be the same. So let's actually do 18, 15. So it's, okay, there we go. So in this case, the best is going to be 20 minus 12. That will give us 8, which is the biggest we've seen minus the smallest current. And so you kind of get the picture. No matter what, like if this one's on the outside, then the biggest will be 40 minus 10, which is the biggest current and smallest we've seen, and so on. So basically just doing these two calculations will guarantee give you your answer. Hopefully that makes sense why. Okay, so let's just keep going now. So we do our two calculations. So the biggest we've seen is a 5, and the smallest of the current is a 2, so that's 3. And then the biggest we've seen, or the biggest of the current array is a 5, and the smallest we've seen is 1, so that difference is 4, so that's why we record the 4. And then we're going to record the biggest and the smallest we've seen. We're going to update it. So in this case, the biggest we've seen is still 5, and the smallest we've seen is still 1. So let's keep going. So this do the same thing. Biggest we've seen is a 5, smallest current is 1, so that difference is 4, and the biggest current minus the smallest we've seen, so that's 8 minus 1, so that's 7. So we update, and then we're gonna, so the min stays the same, and the max turns to an 8. Yeah. Okay, next one. Biggest we've seen is an 8, smallest of the current is 10. So in this case, we just get -2, which wouldn't be good. And you don't even need to do absolute value here, because like I said, since these two are both above the ones we've seen, the answer will always be the bigger number. It'll be the second one. So we get -2 here, which is obviously smaller than this, so we don't need that. And the biggest current is 20, and the smallest we've seen is 1, so we get 19 there. And then we update the biggest we've seen to 20. And last one, so the biggest we've seen is 20, smallest current is 3, so that difference is 17, so that's worse than this. And the biggest of the current is 10, and the smallest we've seen is 1, so that difference is 9, so that's smaller than this 2. And these stay the same. And your answer is 19, where you take this 20 and this 1. So hopefully that makes sense. The algorithm is pretty simple. Just the hard part is figuring out, like, I can actually do this in linear time, but just by storing those two variables, I think figuring out that you don't care about the things in the middle is pretty easy, but figuring out how do I do this efficiently, where like I make sure I don't reuse variables that are together. And the answer is just go linearly and keep storing the best thing so far. And that actually does compare everything to everything else. So by the time we get here, we have the best thing here already. We don't need to actually do all these comparisons. All right, so let's code that. So we'll make a result, and we'll store the like previous big and previous small or something. So previous big equals arrays 0, the last number, so arrays 0 length minus 1. Okay. And then previous small will be array 0, 0. Oh, looks like it's a it's not an array, so I think you have to do like at or something. Let's see. So arrays at or get or something. Get, there we go. Okay, so get 0 and then then the next one will be get arrays dot get 0 dot size. Kind of messy, but okay, I think that's right. Okay, then the next one is just arrays get 0 get 0. Okay, there we go. So now we have to loop through every other array. So we're going to say equals 1 arrays size. Okay. So now we're going to calculate our current big and our current small. Going to be very similar to this. So arrays get I and I. Okay, there we go. And now we just do our two things, right? So the biggest we've seen minus the current small, and the current big minus the previous small. So result equals max of result and current big minus previous small. And I don't think you can do more than 2 variables here in a max. I think you have to do 2. So I think we need another max. Okay, and then previous big minus current small. So just like in this picture, the biggest we've seen is the previous big, and then the smallest we've seen is the previous small, and then the smallest cur and biggest cur. Okay. And yeah, so it's going to be either this one, or the old result. Then we also want to update the biggest we've seen and the smallest we've seen. So pre-big, the max of pre-big, and the current big, and previous small, max, previous small, and current small. Okay, there we go, and return result. All right, and hopefully he didn't screw up. And we did. Okay. Probably screwed up an index somewhere. Let's see. So arrays get 0, 0 size minus 1. That should be the last element. That should be fine. And then this one, current big is arrays get I, get array I size minus 1. That should be fine. Arrays get, that should be fine. Yeah, and then it's going to be result current big minus previous small. That should be fine. Oh, this should be min, right? So when we're calculating the minimum, we want the smallest. Okay. All right, there we go. Okay, so this is going to be linear time now, and constant space, because we just keep track of these 2 variables and these 2 variables and the result. So hopefully that makes sense. Definitely a harder problem than what it looks like from the description, where you're just like, let me just get the biggest and the smallest value. It's actually not super easy to figure out how to make sure they're not in the same array. Like I said, if you didn't come up with this, you can do something like have all the numbers and the arrays they're in, and then do kind of like a left and right pointer starting from the start and the end, and get your first valid solution where your numbers aren't in the same array. Something like I think there was like some other like LeetCode problem where you have like some water in the middle, and then you have like 2 walls, and you're trying to like move the walls closer. The same kind of thing, where you just have to get to the first 2 walls that aren't in the same array. I'm sure something like that's also doable. But for that, you have to do a sort and a lot more work, so this is a lot easier. And so you can do this kind of thing in future problems where, like, if you're just reliant on storing some value, you can just compare arrays and then store that value, and then that would give you the same kind of thing as comparing every array to every other array. So hopefully that was helpful. If it was, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.